All right. Hello, everyone. It's very nice to be here as always. ETHGlobal did an amazing job with this venue and things, so props to them. But yeah, we will be talking through Superfluid today. So my name's Sam. I help lead developer experience at Superfluid. And I'm going to show you how Superfluid works and how you can use it to build money streaming applications. So what is Superfluid? Well, Superfluid is a protocol which enables something we like to call real-time finance. So real-time finance enables you to, amongst other things, stream money with no capital lockups in a way that's 100% programmable and on-chain. All right, so what does this mean? Well, money streaming is this idea of taking any recurring transaction, and instead of setting it in discrete lump sum intervals, I can define what's called a flow rate and send you a certain amount of tokens per second, and that money just trickles into your account in real time, right? So it's a really, really cool opportunity to bring recurring payments into Web3 natively. And what it does is it creates this really cool link between the value you provide and the value you get in return for that, right? So if I'm an employee and I go into my job and I clock in at work, right? In a lot of cases, what I'm doing is I am working and then I'm waiting 2 weeks to a month to actually get my paycheck. What if I could clock in and every single second that I'm providing value, I got value in exchange via something like a money stream, right? And what this kind of thing does is it enables you to send money with no delays. There's no unpayment risk, right? For every second you work, you get paid. And there's also no intermediaries because this is all done on chain. And we live in a world with at least less intermediaries here in Web3. So the protocol it's not a layer one, right? It's not anything like that. It's not a roll up. This is a smart contract framework that is made for the EVM, although eventually it will be probably chain agnostic and environment agnostic. And what it does, it allows you to create these open-ended agreements between two accounts, right? So what you do when you create a money stream is you engage in a kind of agreement, right? So I can opt to send you 1 token per second, right? And as soon as I've done that, I've sent an on-chain transaction which says that now my balance is going to be decremented by 1 token per second, and yours is going to go up by 1 token per second, right? So this is really cool for a lot of reasons, but what's really interesting about it is that these tokens that enable this, right, can have really interesting ways that their balances can be changed in accordance with those agreements, right? So in order to actually make this happen, right, this is pretty innovative. Like in order for you to actually send money on a per second basis, normally a lot of you are probably thinking, all right, am I going to have to call it something calling transfer every single second to make this happen? And that's not the case, right? We built this additional token type, which is plugged directly into the Superfluid Protocol and is compatible with many of the other features you're used to with tokens, right? So we inherit all of the standard ERC20 methods, and you can use them anywhere in Web3, right? So we have 2 types. One type of super token is one that's just deployed out of the box as a super token, right? So this is one that, you know, maybe you deploy it tomorrow and you know the super token a super token exists. So you don't want to deploy a wrapper around an existing token. We also have wrappers, right? Because we know that composability is so important. So you can wrap DAI, you can wrap ETH, you can wrap USDC as a super token and be able to use it anywhere else in Web3. So these agreements that I mentioned, right, these are these connections between 2 accounts. And what they do is they allow you to calculate something called a real-time balance on that super token. So on the super token itself, what you can get is based on like how many money streams you have outgoing at this given point in time. We can calculate what your net flow rate is. Right, so I used the example earlier where I am sending out 1 token per second and someone else in the audience is receiving 1 token per second. We can calculate your net flow as whatever that is when you combine all the different money streams you're sending and receiving at once. Right, so if we have that, right, we also have the block.timestamp value, which is changing for us every single new block. So what we can do is anytime you want to create a new money stream or do something else with your super tokens, we just calculate, all right, how many tokens you have in this moment before we perform that next state changing operation, and everything shakes out properly given the accounting that happens on the token. If you have any questions about how that works specifically, I'll be standing right over there after the talk. We can get into the details, but the thing you need to understand is we're doing this by hacking the block.timestamp value to move money effectively for us, right? It's pretty cool. The other cool thing about this is that because it's a smart contract framework, there are a lot of things we built into it to make it programmable, right? So you can provide like an access control layer so that there's something that's very similar to ERC20 approve methods. So I can grant you the ability to open streams on my behalf. And we also have these things called super apps, which you see here down in the middle, that are these cash flow aware smart contracts that can react to specific events. So if I send a stream into a contract, it can react and then do something for me, right? One example we'll go through later on, we'll actually get into some code, will be one that can take in a stream, and the second that it starts receiving those tokens, can redirect those tokens to whoever the owner of that contract is. So these Superfluid apps are, again, very important in terms of painting the picture of the potential of what Superfluid can offer, right? You can put anything you want inside those callbacks, not just like open a stream for me, you can do anything else. And what this does is it allows you to chain all of these different operations together and form a crazy network of cash flows, right? So this is Superfluid right now as it's deployed on Polygon with each individual node representing an account and all the connections between nodes representing cash flows, right? So all of the teams that are building products on top of Superfluid are participating in this giant network of cash flows. I'm actually impressed that it rendered properly because this is a lot of information, but it's really cool. And what you can do if you build on Superfluid this weekend is build an application that plugs into this giant network of cash flows, right? So you can grow this network and you can also tap into it, right, in terms of a user base. So with that being said, let's talk through prizes at ETHMexico, and then we'll get into some actual tactical building stuff, right? So again, if you want to go take advantage of the network I just showed you, there are some opportunities here. We have 10K worth of prizes in USD, one for the best overall project, one around DeFi, and then some other general prizes here as well. If you have any questions on them, please feel free to come up to the booth and we can clarify them for you. And yeah, so in terms of building on us, there's a couple of things you want to know about. One of those things would be our developer console. We'll use this in a little bit to just see the effect of creating money streams and deploying cash flow aware smart contracts. We also have a dashboard that's really cool. If you come up to our booth, you'll see we have this huge TV monitor that will show the balance ticking up in real time. So if you want to see how that works, right, and even get a stream yourself, you can come up to our booth and we can show you. And then we also have an SDK that I'll make use of here in a demo in just a second. But this is really useful because it allows you to interact with the protocol without using any Solidity at all, right? As long as you know TypeScript or JavaScript, and most of you devs here, you probably have at least dabbled in it if you're here, you can open streams in just a few lines of code using that SDK. So let's build. What I'll do here is I'll share my screen in just a second, but I want to give an overview of one of the applications I want to walk through briefly to give you an idea of how simple this can be to create smart contracts that interact with our protocol. So we're going to create this thing called a money router, right? So it's going to allow you to manually send a money stream into a contract and then manually call a function on the contract to send a stream out of that contract to an address you choose. Right? It's going to look a little bit like this, right? One of those super apps I showed you earlier, which can take streams and automatically send them out. It's just going to be a little bit less fun because it's not going to be automatic. I'll show you in a little bit an example of a contract that can automatically, the second it takes in a money stream, send it out, but we'll get into some of the more advanced class stuff in just a second. So you can find all of these examples if you want inside of our repository here. I'm going to make sure you guys can see this, but inside of our repo we have a super examples folder. And what you can do is you can actually just plug in and fork some of these things this weekend if you want to build a Superfluid related project. All of these, we try to make them so that they have really, really good documentation, good comments. And if you have any questions about them, we'll be here. But the example we'll be using first is just this money streaming intro example. So you're welcome to come back here. You can fork this repo if you want and follow along if you'd like, or just try it later. But if I pull it up here, I'll go to the contract itself and make sure you guys can see it. Zoom in just a little bit more. We have some boilerplate here up top, right, where I'm importing a bunch of contracts. And what I'm doing is I'm using this library called the CFA v1 library to allow me to open a stream in Solidity in 1 to 3 lines of code apiece, right? So it's fairly simple. So once I have this all set up in the constructor, right, I have some state variables that I declare up here. But in the constructor, what I'm doing is I just deploy, or I guess I instantiate this library here. And from there, we can actually get into this contract and use it to start opening up streams. So there are a few key functions we'll use. There's some access control stuff here up top that I won't really go into today. But the key functions that matter here are, one, sending a lump sum into a contract. You might want to just send like a lump amount of a token into the contract. So we have a function that's going to let you do that on the contract itself. We have a function that's going to let you create a flow into the contract. And then we have another function that's going to update that flow into the contract or delete that flow into the contract. And now that we have streams going into the contract, we need to also send streams from the contract, right? So I have the same exact 3 functions, but coming from the contract. So what I'll do is I'll fill in some of these functions just to give you an idea of the simplicity here. Inside the, let's go to the create flow into contract example. Inside this, all I have to do is call cfav1.createFlowByOperator and pass in the sender, the receiver, the token, meaning the super token I want to use, and the flow rate, right? So very simple, literally 1 line of code, and I can create a stream into the contract. In terms of creating a stream out of the contract, right, it looks almost exactly the same, but there's no by operator thing here, right? And the reason why we have to use this by operator bit in the create flow into contract function is that once I create a stream into the contract, like if I were to pass in like the message.sender being like the contract itself, that's not going to work because even though I'm calling this contract, or I'm calling this function on the contract, the actual message.sender on that function call is going to be the contract itself, right? So this is just tracing the value of message.sender within your individual calls. But here what we can do before we actually make this call is use our ACL features, which allow us to provide access to a different account to open a stream on my behalf, right? So this is just like an ERC20 approve, where I can allow somebody else to create a stream for me, right? It's fairly simple, and we'll go through a script that shows you how to do that as well. Okay, so we have that function. I'm just going to copy this over to the update example, and it'll be almost the same exact thing, except I'm just going to change it from create to update. So that's pretty simple there. And I will do the same thing for this example, right? So instead of just create, I'm going to change this to update. And it's pretty simple. I just have to make sure that the flow actually exists, right? If I try to update a flow that doesn't exist, that'd be kind of nonsensical and it's going to revert. But if I update the flow with a new flow rate itself, it'll work. Okay? So I'm going to leave it there for now. There's going to be some functions here we're not going to implement just for the sake of time. I don't want to be too redundant for you guys. But what I'll do is I'll just deploy this contract using our little deploy script here. We'll do this live, which is always fun because it means I might have to debug live, but hopefully not. So this is deploying, and while this deploys, I want to show you a couple of other useful tools, right? So I mentioned this thing called the Superfluid console. This allows you to just search an address and see everything that's going on with that address. So if I copy and paste in an address that I'm going to use quite often here, which is just this one, it'll pop up on every network it's being used on, and I can track everything that's happening with it, right? So I can see all of the DAI that's flowing on testnet. This is all fake money, guys. Don't worry, this is fake. But you can see all the money streams that I've created. You can see the tokens that I hold. Right? It's a really, really useful tool. So if you're building something on Superfluid this weekend, I highly recommend you check it out. We also have dark mode. We know everybody likes dark mode, so that's another plus. But if I go back into VS Code here, looks like we had a little compilation fail bit here. See, I told you, we got a debug live. This is what we love. Let's go back in here. Yeah, I think I just forgot to save. Let's redo that. So as soon as this deploys, we'll be able to create a stream into this contract itself. Same thing here. Let's figure this one out. New flow rate. There we go. See? We make mistakes too, guys. All right. So I have this. This is deploying for us. All right. We have another one, which is always also fun. Looks like I did the same thing here just for the other example. All right, same thing. Let's pass in new flow rate. And we're running a little bit ahead of schedule on time, so we should be okay. There we go. All right, so this is compiled. And then the second this deploys, what we'll be able to do is send some funds into the contract itself and then open a stream from that contract to a different address. Okay, so this is just loading for me. Alrighty. Gotta love alchemy with the RPC. All right, and I do have a backup example here, which is something I'm glad I prepped. But the goal here will be, as soon as this is deployed, all right, it looks like it did just deploy. As soon as this is deployed, we'll be able to create a flow into this contract and then ultimately create a flow out of the contract, right? So first I'm going to approve a token send into the contract. Okay, so we'll go here into this token approval function. I'll send this transaction here. So instead of deploy, I'm just going to approve this. Token approval. Just like that. So I've just passed in this address of the contract. And then here what I'm doing for the approval is I'm just calling approve on the dYdX contract. So this is just going to approve this dYdX token, right? This which is successful. This is going to give the approval on the dYdX token such that I can then send money using this function call here. So do the same thing where I'm just going to pass in the contract address to this one. So we'll send a lump sum into the contract. Alrighty. And then I can run this script here. Okay. I'll paste that. So now we're going to send some money into the contract. And in just a second, we'll be able to see this money also inside of the console. Right, so as soon as it receives funds, I'll be able to search it just like I was able to search this address. And we'll be able to see that this now has some super fake DAI tokens. Okay? So let's make sure that approved. All right, we just successfully sent funds to the money router contract. And oh, that's not what we want to do. We want to paste in the address of this contract. Okay, so I'll paste this in. Cut this off. And in just a second, this should show up for me. But now that we've done that, what we can do is now create our stream into the contract as soon as we use this ACL approval bit. So remember, this ACL feature allows me to approve someone else to open a stream on my behalf. Okay, so in this case, I'm just going to approve the money router contract itself to open a stream on my behalf. Okay, so we're going to create a flow into the contract using this script. I'll paste it in just right here as the address. And then what we do is we use the Superfluid SDK. I guess we got to go into the ACL feature first. So what we'll do is we'll use the Superfluid SDK to approve the money router contract to spend some tokens for us, right? So this is just called update flow operator permissions. We pass in the address of the money router. We specify the super token we want to use, and then we give it a flow rate allowance, right? So this is just the amount of tokens we can create in terms of flows sending out per month. All right, so this is what this amount correlates to. This looks like a very big number, when in reality it's just the number of way we're going to send per second. Okay, and this permissions value will just grant all permissions, right? There's like a bit map value here you can look up in our docs. If you give it a 1, it's just going to give you the create permissions. In the case of a 7, you get all the permissions, right? So you can do anything you want. All right? So let's load this again so it can show up when we're back here. But let's call this ACL feature, grant that access, and then create the stream from the contract or into the contract from us. Okay? So let's call this function here using this script. Alrighty. So we'll run this ACL approval. This is just going to offer our approval. And then the second we're done with this, we're just going to call the create flow into contract function on the contract itself. And then because the only 2 values it takes, if I search create flow into contract, it's just going to take a token and a flow rate, and then it's going to handle the rest for me in here. I can just pass the token I want to use, the flow rate, and I'm good to go. I'll be streaming money. Alrighty, so this is all set up properly. And then I'll run this one. So the second this loads, we'll be able to see money being sent in real time into the contract. All right, so this is the contract itself. See, there we go. It's popped up on Guerli. We can see it has a balance of 500 tokens, right? So we've been able to send that lump sum amount. So it's sitting on 500 tokens. And then the moment this one actually finishes, we'll be able to see that money being sent in real time. Okay. Just a second here. Some other features here that might be relevant in terms of checking out like protocol level stuff are the subgraph, right? So what you can do is write custom subgraph queries in line, which is pretty awesome. We use this quite often for just like looking up internal data ourselves and playing around with the subgraph. People ask us like how they can get specific types of data within their applications, and usually the best place to go for this is this subgraph explorer console, right? You can just use this to pretty easily just sleuth different data you want to get, look up specific things. You can use events. So I highly recommend using this as a place to get data within your applications. All right, so it looks like this transaction's hanging for me, which is no fun. But in the end, the goal of what we're trying to do here, and this is what will happen as soon as we have this propagate, is to get something that looks a lot like this, right? So this is an example I prepped beforehand just in case we had transactions not processed fast enough for us on stage. And what we can see here is we originally had a balance of 500, but then we sent streams from the contract, or sent streams into the contract, I'm sorry. And when we did that, we created a flow that is going to send the equivalent of 33 tokens per day, or about 1,000 tokens per month. And we have about 6 tokens that have been streamed from the time that I opened this to right now. So money is flowing real time in this example, and this is the end result of what this function will do as soon as it actually goes through. Okay? So that's the manual example, right? That's manually sending a stream into the contract. And if we wanted to, we could just call the create flow from contract function to send streams from the contract in a manual way, right? This is something you guys can all do very easily. But what we also want to show you how to do is create these programmable applications where you can do things automatically, right? Like let's say that I want to send a stream into a contract and have it automatically, the second it gets funds, send a stream out of the contract, right? And where this becomes really interesting, I'll go back to my slides here, is in the case of like tokenized cash flows or revenue-based financing, right? So there's a contract that we use for the base of a lot of our examples called the Tradable Cashflow that can receive streams and send them out. But the other cool thing is that it's also an NFT, right? So you can imagine, let's say I'm a business, let's say I'm a subscription-based business, and I have one of you in the audience paying me for a SaaS subscription. What happens in the Web 2 world is a lot of people that run SaaS businesses will raise new rounds of financing all based on existing revenue, right? It's just revenue-based financing, right? Instead of having to dilute themselves and sell a portion of their company to raise more money, what they'll do is they'll say, okay, financial markets, I'm having somebody pay me $1,000 a month for my SaaS subscription. Instead of me taking this money and waiting to get an additional $1,000 every single month, why don't you pay me $11,000 now, and I'll redirect the entire subscription value to you, so you make $12,000 throughout the year and gain a $1,000 profit, right? That's a simplified example. Right? There's obviously going to be other things that underwrite that transaction, but what if we could bring that exact same model into Web3? And that's what the Tradable Cashflow does, right? It lets us tokenize these cash flows and plugs them directly into DeFi. So again, sending streams into the contract, the streams are automatically routed to the owner of the contract, and each time the contract is traded, all of those cash flows go to the new owner, right? So you guys could do really creative things with this where maybe you split a small portion off as a fee to somebody else or add additional crazy features into it as well. But I'll show you how we actually can build this in just a few minutes. So again, back in this super examples folder, if you go to the tradable cash flow example, you can fork this yourself and start playing around. But this one is pretty simple to set up. And I won't go as in detail as I did with the last contract because transactions seem to be taking a little while to actually go through. But what I'll do is I'll walk you through the key functions on it so you guys can go in and take a look yourself. So if we go to the tradable cash flow contract here, we can see that it's really, really simple. Right? All it's doing is it's deploying an NFT, right? So this contract is inheriting from an NFT contract, and it's inheriting from this redirect all contract too, which this redirect all contract has all the cool functionality in it, and I'll go through that in just a second. But it deploys an NFT here with a name and a symbol, and mints one of them to the owner of this contract, right? That's it. Really simple. The NFT stuff is all the stuff you guys are used to, but the new stuff is all in this redirect all contract. So the only interesting thing we have here on the NFT contract is we use this before token transfer hook. This is a hook you can use that you can actually see in the Open Zeppelin interface for the ERC 721 standard. But you guys can just call this change receiver function inside of the before token transfer bit to make sure that before the token itself is actually transferred, if it's ever sent, that all the streams are deleted to the existing owner and sent to the new owner. So if we go into the redirect all contract, which is again where all the cool logic takes place, we're doing all this superfluid stuff here up top. We're importing all this boilerplate. We've got some events we declare you guys can use. We're using the CFA library to make it really simple to open streams. We add some stuff in the constructor. We also initialize the library here, just like I showed in the last example. But then what we do is we do something called registering the app with the Superfluid Protocol. Right? So what this register app bit does is it will allow the Superfluid host contract, which is like the brain of the Superfluid Protocol, to call these specific functions each time like one of these operations takes place. So all you have to do is deploy this contract and send a stream into it, and one of these functions, one of these callbacks will run for you instantly. So it's called the after, in the case of a stream being created in the contract, it's called the after agreement created contract or function. And this logic inside of here will run automatically for you, right? So it's being called by the Superfluid Protocol, and inside of this you can do whatever you want. So in the case of the update outflow function, let's go to it here. What we're doing, the simplified way to explain what's happening here is we're just checking the current state of the contract itself, right? If no stream yet exists into the contract, what we're going to do is look at how much money is coming into the contract, and then we're going to create a stream of equal amount to the owner, right? That happens down here in this create flow example. If there's a stream already existing into the contract and the stream was updated, right? What we can do is just make sure that it's updated so that it mirrors the amount coming in, and we need to make sure that amount equals the amount going out. And in the case of a deletion, all we need to do is delete all the streams going out of the contract, right? So pretty simple, right? Simple like if-then statements to get this really cool functionality. And then in the case of the changing of receiver, again, this is just going to be called each time that the token itself is actually transferred. What we do is we check who is the current receiver. All right, that receiver should no longer be receiving these streams, so we delete them right here. And then we need to create streams to the new receiver, so we can see who the new receiver is, and we can create a stream to them equal to the exact same amount that was being sent to the old owner, right? So it just matches up. And again, this is all here. You guys can fork this, use it in your own applications, make it better. I'm sure there's gas golfing opportunities in here if you're so inclined. Feel free to go crazy, but that's the idea there, right? So in the case of this contract, it's going to receive tokens and send them out automatically so that the balance of the contract is always zero, but the owner has this asset that is now a tokenized cash flow. So again, highly recommend you check that out. But to wrap up here today, there's a couple other things I want to mention, right? The first of them is this thing called Superfluid Reactor. So there are quite a few teams, including some of the logos I've shown here, that have built pretty good traction or raised money building a project on top of Superfluid, right? And the Superfluid Reactor program, who is also kind of spearheaded by Yao here in the back, she'll have a Soleil tag. You'll see her as Soleil in Discord. She's helped lead this, but what we've done with the Reactor is formalize some of the help we provided to projects like yours that might build this weekend. And if you guys want to raise money, we'll provide coaching on how to raise money. If you guys want help shaping your idea, we do that as well. If you guys want technical review, technical help, we can do that too. So again, it's something I just want to plug briefly because we do really value our developer community and our ecosystem. And I think that you should know that if you are considering building on Superfluid, you have resources. And the final thing I'll leave you with is something kind of fun that I'll plug really briefly. It's a podcast we just launched yesterday called Devs Do Something. So our first episode was with Rahul Sitharam from Connext, the CTO of Connext. And the methodology behind this was, again, we really value developers. We looked around at all the podcasts out there, and there aren't that many like really highly technical Web3 podcasts. There's a lot of really great content out there, but we want to go super deep. So with Rahul, for example, we went deep into like how they do design and like actually launch new features at Connext. We went behind the scenes on how they approach security and testing. We walked through like literally like their GitHub actions and stuff. So if you're interested in some tech alpha, I highly recommend you check out the Devs Do Something podcast and give it a listen, and also recommend people you'd like to have on it. So That's it for me today. Sorry we had some of those transactions not work live on stage, but I hope you guys consider doing something with Superfluid, and if you have any questions, please feel free to find me in the hallway over there. Thank you.